In this video, we're going to be looking at an introduction to logarithms. And first of all, what are logarithms? Well, a logarithm is the inverse of an exponent. And what do we mean by that? Well, take a number x. If you take the exponential of the number x, you can turn it into a to the power of x, where a is just some number. But because the logarithm is the inverse, or the opposite of the exponent, then if you take the logarithm, it will turn a to the power of x back into x. In this video, however, we're most interested in looking at the basic definition of a logarithm, which is this formula here. So we've got two equations. A to the power of x is equal to b, and x is equal to log a of b. And that double arrow in between them tells us that those are two equivalent ways of describing the relationship between the numbers a, b, and x. Now, that little letter a next to the log, that's called the base of the logarithm. And you'll be glad to know that this entire formula is in your exam formula booklet. Now here on the right-hand side of the formula, we have some conditions. So a and b need to be positive, and a can't be equal to 1. That's just to make sure the logarithm works and is well behaved. But this part here is the actual core of the formula that you need to be most familiar with. So let's move the whole formula over to the sidebar and focus on that core. And let's look at this example. So 5 to the power of 2 is equal to 25. That's in a to the power of x is equal to b form, with a equal to 5, x equal to 2, and b equal to 25. The formula tells us that we can rewrite that relationship between the numbers as log to the base 5 of 25 is equal to 2. And that's one way to deal with logarithms, just relying on the formula. But it's even better to be able to read logarithms. And what do we mean by that? Well, log to the base a of b is a number, and it's the number that answers this question. What number do I need to raise a to the power of to get it to be equal to b? So there's our formula again, and that question is really what's built into that formula. And here's an example. So what is log to the base 2 of 32 equal to? Well, let's start looking at powers of 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. So the power I need to raise 2 to in order to get it to be equal to 32 is 5. That's the answer to our question, and therefore log 2 of 32 is equal to 5. Now, there are two special logarithms you need to be familiar with. There's ln of x, which is equal to log to the base e of x. And the logarithm to base e, where e is a special exponential constant, sometimes known as Euler's number, that's called the natural logarithm and is usually written as ln of x. And this is something you'll come across in your studies of calculus. The other one you need to know is log x, when it's equal to log base 10 of x. The thing is, 10 is a very common base for logarithms in many practical applications, so you'll sometimes see log to the base 10 of x abbreviated simply as log x. And finally, why do we use logarithms? Well, logarithms have a lot of important practical applications, especially in the sciences, so you need to be familiar with them. But also, using the logarithm function on your GDC, you can answer questions such as, what power do I need to raise 7 to get it to be equal to 213? Now, 7 squared is equal to 49. 7 cubed is equal to 343. So somewhere between 2 and 3, we expect there to be a number, and if we raise 7 to that power, it'll be equal to 213. And also here, the fact that many of these questions will get answered in your GDC means that you need to make sure you're familiar with how logarithms are input and displayed on your GDC. Now let's look at a quick worked example. And it's a logarithm question, so let's remember this formula from the exam formula booklet. And how about part 1? It's asking us to solve x equal to log base 4 of 64. This is a question we'll be able to solve by inspection, and that just means looking at powers of 4, because 4 is the base of the logarithm. So 4 to the power of 2 is 16, 4 to the power of 3 is 64, and that means that log to the base 4 of 64 is equal to 3, because 3 is the power we need to raise 4 to get it to be equal to 64. But how about part 2? This one's a little bit trickier. 7 to the power of x equal to 213. This we're going to solve using our GDC. And now's the time to remember this formula, because 7 to the power of x equal to 213 is an a to the power of x equal to b form. But we can rewrite it in logarithm form as log base 7 of 213, and that's going to be equal to x. And that's something we just put into our calculator, and it will tell us the answer. So we can write that down, and then just do not forget to round your answer to 3 significant figures. One important thing using your calculator with logarithms is make sure you're using the right base. If you had a different base than 7, your calculator would give the wrong answer. Something else to be aware of is it might be possible to solve equations like this using your calculator's equation solving function, in which case you might do something like this. So you can just put the equation 7 to the power of x equal to 213 into the equation solver, ask it to solve for x, and the calculator will give you the answer. And let's end with a brief recap. So a logarithm is the inverse of an exponent. The logarithm log a of b is defined by this expression, which is in your exam formula booklet, and where the number a is known as the base of the logarithm. Log a of b is the number answering the question, what number do I need to raise a to the power of to get it to be equal to b? You also need to be familiar with these two special logarithms, so ln of x, which is log to the base e of x, and log of x as an abbreviation for log base 10 of x. And finally, logarithmic equations can sometimes be solved by inspection, or else by using your GDC. Don't forget to check out all our other fantastic revision resources here at Save My Exams.